of national impact. And this session today is an opportunity for us to hear thoughts from people who are on the front line. For example, the administrative support, scientific support, scientific vision and direction, and also we have renowned academics on our panel. I think it would be great to hear their perspective as well on what they think about the bridging between academia and industry. So the structure of the session is such. I'd like to start with a few questions and hear thoughts from Mr. Shiraz, who's the Executive Director of QuantLase Research and Development Center. And then I'll have questions for Dr. Pramod, Director of Research, QRDC, and then for Dr. Agarwal and Dr. Costa. I'd like to start with the questions. So the structure is I would have just two questions for each of the panelists and would like to hear some thoughts. My first question for Mr. Shiraz. So when enabling, we talk about the ecosystem perspective, and when we enable a broader ecosystem for product-led innovation, particularly drawing from your experience in supporting our chip development program, where do you think where does executive intervention really makes the greatest difference?
Can you hear me?
Yes, thank you.
So the question you ask is about the executive intervention or the executive support for the product-led innovation, right? Is that the question? So I think you are expecting what is the role of the management or the executive committee
Please.
for the advancement of the development?
Yes, please.
So I think in a short answer would be a quick release of funds as and when required.
Right.
And I mean, on a serious note, and giving you a detailed answer, I mean, the answer lies within your question that a product-led innovation, right? So innovation and invention, they are kind of words which are used interchangeably, right? But innovation means taking further the invention in a collaborative way. So definitely, as we discussed in our previous session also, that we are trying to bring the ecosystem here, and there is a lot of collaborative work that is required to bring the design technology, to bring the testing technology, so that we are enabled and we can move towards the product development. So definitely, the management support in this regard will be to expedite those collaborations and to formalize the agreements and MOUs so that it can support the development team.
Thank you. Thanks very much. I do appreciate this is also a problem, I would say a problem statement on this particular front is that enabling an ecosystem is not just coming up with an innovation idea, it's about creating an entire end-to-end framework to execute on the idea. So in this regard, I have seen the administrative support. It's really one of the key pillars of the strategy, and honestly, our product development program wouldn't have been standing here today if it wasn't for support from our executive management. Thank you. So one more question. I'd like to hear your thoughts and your perspective on what do you think, what do you think about the roles that holding groups, for example, our international holding, what type of role these holding groups can play in creating an effective product development and a deployment corridor across them in our region?
The role of the holding company for, we can say that for the product development, deployment, and I would stay specific to the PIPU because this is one of the product that which is at the stage where we are moving towards the product commercialization or bringing it to a product level. So as I think most of you are aware that the biggest data center at the moment, it lies in China with a size of about 1.3 gigawatt. And there are further data centers that have been announced from 2 gigawatt to 5 gigawatt, and the biggest being the 5 gigawatt. Anyone of you aware that where this 5 gigawatt project lies and where has this been announced? Are you?
No, sir, I'm not.
So this 5 gigawatt project is the data center. Yeah, that is a collaboration between IHC, G42, and OpenAI. This project has been announced in UAE, right here in Abu Dhabi, and it's based on NVIDIA Grace Blackwell chips. So this data center will be here. As you're aware that with the NVIDIA Grace Blackwell chip, they have provided, you know that the most of the NVIDIA chips, they are based on the CUDA architecture, right? About 90% of the AI development or the AI framework is based on the CUDA framework. And NVIDIA has also provided the CUDA Q platform, where Q is for the quantum, right? So it can easily be integrated with the QPUs, which is the quantum photonic units, or the PIPU. So the framework is already there, right? As soon as we are ready with the Photonic Intelligence Processing Unit, we have this data center available where it can be complemented with the NVIDIA chips, and it can be well integrated with the system. So, uh, for your question, from the point of view of the support from the group level, you can see that this development is coming here very soon, and as soon as we are ready with our product, there is an opportunity.
Thank you very much. There was one point which you mentioned about NVIDIA Blackwells. We all know that NVIDIA Blackwell chips are not just sold to the UAE, but they're actually export controlled. They're cleared through export controls, which means they're made specifically for the UAE market. Now, on this line, I've one question. I'd like to hear your thoughts on the lines of export controls. You've seen, you've provided executive support for our chip development program. What's your opinion on the importance of export control framework for product development, specifically within the MENA region? Do you have any thoughts on that, please?
I think your question was originally meant for Ms. Malak, who
Yes,
has not
indeed.
joined us
Yes.
for some reason. So, for the export control, I mean, I understand that the export control is mainly, and it depends on the geopolitical situation as well, right? We have tried to secure some export control licenses in the past for this region, which we have been successful to secure easily. The main thing that they look for, or the export controls are in place, is your product are not going to be integrated with the military use, right? And definitely this is where we separate our development, and we are mainly focused on the commercial development and the commercial deployment of our technology. So I think with this clear statement, we should be able to clear those export control licenses.
Thank you very much. Next couple of questions for Dr. Pramod, Director of Research, QRDC. The first question, I'd like to hear your thoughts on, in the context of the Middle East, you are obviously among the very first people, figures to explicitly frame the challenges of lab to fab and fab to deployment. Having now directed this program in terms of scientific vision, what would you identify as the critical and a missing strategic pillar when translating a strong research idea into a manufacturable and deployable chip?
Thank you very much, Dr. Salman. It's really a crucial and interesting question you asked. So as far as my understanding and my experience is concerned over here, so what the pillar is missing is that is translational execution layer. Translational execution layer, what does it mean? It means it's a structured capability to deploy your idea and convert it into product and deploy in the market for you as a useful case. So your brilliant idea and publication are necessary, but these things are insufficient in the absence of this translational execution layer. So this is the missing point actually. So what does it mean? Translational execution layer is that you have to have your ecosystem here. So with the part of ecosystem, you have your designing center, you have your packaging, testing, and manufacturing. So foundries. So all these are actually you should have in your in-house productization. So suppose, for example, at component level, if you test the chip, it's working well. But when you convert it into product, it will not, it will fail.
Yes, that's true.
Make a
Yes.
functioning. So each and every step you need to test and testing and packaging everything. So you have to have your in-house testing and packaging facility.
Right.
So I think this is the missing point. What I feel is the crucial point
Right.
we miss all the time. So, in my opinion, actually, we are we are trying to bridging up these things, and as I already discussed in the introduction, we want university, we want industry. So, we need university or university researcher to validate industry idea, to validate this science. But university also need to, to industry for productization or to deploy this product in real market.
Right.
So both actually we need both. Not a single model will not work.
Of course.
We both model will work all together to really get a productization. Then you can say that okay, disruption coming into market. Otherwise, disruption meaning is nothing.
Right.
So this is my experience about this.
Thank you, sir. And I think this nicely brings us to my next question, because you mentioned positioning a bridge between industry and academia. So my next question to you would be, what were your thoughts on, if you look ahead, what role do you see for QRDC playing in bridging the MENA research and innovation landscape with
So-
cutting-edge industry?
So QuantLase is, you can consider QuantLase as a translational engine between idea to productization.
Right.
So you can consider QuantLase something like that. So because laboratory level experiment or it's a proof of principle experiment, it will give you the possibility, and industry will give you the productization or product or productivity. And QuantLase will give you what is the thing which is capable to transfer from lab to public domain.
Right.
So QuantLase is a fascinating platform to give you what is transferable from lab to public domain.
Right. Thank you, sir. Thank you very much. I really appreciate all the insights. Indeed, and this is exactly the type of comments that we got from our chip technology collaborators as well, according to...
In addition to your questions,
Yes,
actually, around you in the market, people always ask us quantum technology always there.
True.
So people call this as disruption, quantum disruption technology. But in my opinion, I don't think so it's a disruptive, because unless and until you have fully functioning quantum computer in the market. So it's up to you whether you feel disruption means any quantum enabled technology coming to market is a disruption. So you can call it disruption because few technology based on quantum phenomena already there in the market. But if you really feel disruption comes from fully functioning quantum computer into market, then it's not there. It's not. So we need to think, because fully disruption comes from when we have our in-house facilities, in-house productization, in-house fabrication, in-house designing, in-house testing, in-house packaging, all these things when we have, then we can say that, okay, quantum disruption is coming to the market. But not at this stage, to the best of my knowledge. I don't think so, quantum disruption already here. But depending on the useful case like a QRNG, QKD system, which is already there in the market. So if you say that this is quantum disruption, okay, I'm happy. But in my opinion, when quantum computer fully functioning, error-free quantum computer will be there, then I can say that this is really a quantum disruption. So today's gathering is really actually idea of this gathering is to exchange our knowledge, our idea in order to make it happen. How to do that? How to transfer this technology from lab to public domain? So the moral of the story about this gathering is this. So it's not really a meeting. It's a exchanging our ideas, our experience, how to implement our experience to really get a quantum disruption in real life. That's.
Thank you, sir. Thank you very much. That was very nice to hear the perspective, and I'd just like to put something in from my side as well. From one of our industry partners, Lucida Photonics, we got the feedback that they thought of us as a bridge between research and execution, which I think speaks volumes of our strategy, and it's very much in line with what we've heard from the panelists today. That brings me to our esteemed panelists from the university. So I have just two questions for both of the panelists. The first question would be, based on your experience with university and research and academia, and now the talks that you've heard today, the pressing issues that you've known about today. So the first question is, what's your opinion on the bridge, the gap between research innovation and industry cutting edge? What would be your thoughts about what do you think would be the best strategy to bridge the gap? And the second question would be, for your own research domain, ultimately, if it leads to any productization, what are the barriers that you see to the eventual productization? So it's these two questions for both of you, please.
I'll take the first question. Am I audible?
You can speak a bit.
Hello?
Yes, yes.
So I think answer to your first question, which is again the reason why probably the both of us are here in this setting, is I'm borrowing words from what Dr. Pramod said a while back, which is I think presence of an academician in this kind of a setup kind of validates the theory.
Right.
So of course we have an idea, and the feasibility of that idea, I think, starts from the theoretical check. So if a person with the right kind of expertise and knowledge kind of validates that idea on paper, then it's like a double confidence to the person who's finally implementing it, executing, and finally probably putting it down on a chip. That confidence flows from that. So I think the theory behind an idea would be the starting point to any product which is finally seen in the market. So that's where I feel the role of an academician with a knowledge in that particular domain, in terms of it could be math work, it could be simulations, it could be number crunching, it could be a mix of all these skills. But once we have that that start from the theoretician, that yes, this is a feasible thing, it's doable. Of course, how to do it is the job of the other set of skills, is another set of people who would do that job. So I think that's the expertise that the academician brings to the table. Would you like to add to this?
Thank you. I do agree with Dr. Vastav. She's right. And about the second question is like what difficulties we are facing as an academician. So at a very beginning, of course, I worked as a postdoc in a university where I feel that research is a bit easier comparatively, because there nobody is going to ask about the timelines, the deliveries, and the other things, because they just want to show their idea whether it is working or not. Later on, I just worked with the MIT company in Singapore, and there I feel that was smart. And there I feel that if you need a development in research, then of course there is a team which work all together for the development of that idea, for that research. And that team, in my opinion, maybe at the very beginning level, so it's not possible in academia. So always we need our support from the industry who can believe in us and provide us the support. Because lots of things, today I came to know there are lots of things which are required for developing a prototype and just deploy it in the market. So as an academician, I don't think so that is possible without a team. And also I feel that QSG is a wonderful team I have seen from very senior level to the ground level. Everyone is dedicated towards like that work to be completed within the particular timeline or the domain. Thank you.
Thank you very much. So the points made by Dr. Costa and Dr. Agarwal strongly agree with obviously specifically the first point, and I'd like to relay that example to our chip development program. When we started with developing the photonic chip, obviously the very first concept was put forward by Dr. Pramod. And when I developed the chip design, the schematic and the component, I had to verify it with him, and when he said, yes, this looks theoretically good, proceed, then we proceeded to the design, validation, and manufacture. So definitely an initial vision and oversight is what's definitely needed to set an industrial program, which is calibrated for product delivery. Product delivery outcomes is absolutely needed. And thank you very much, both of you. I really appreciate your feedback. Thank you very much, Mr. Shiraz. Thank you very much, Dr. Pramod. It's been a pleasure. And of course, we take a great pleasure in our program, not only the chip development program, but other parallel programs that we've started. Some we've started, for example, the data storage on the 5D optical storage program, the QERNG program, and the rest of the innovation platforms within QRDC. We're very proud of this, and thank you, obviously, to the executive management for enabling a sustained platform. And thank you very much, everyone. It was really a pleasure to host all of you, and thank you, everyone. I think that brings the forum to conclusion.